This is your Chapter 7 Carousel review. We'll be going through all of the sections of Chapter 7, 7.1 all the way through 7.7, and working through a few practice problems of each, and that way you can kind of go through them and look and see how to remember how to do some of these, or just to make sure that you're doing them in the right way so you have success tomorrow on the test. Our first examples come with taking powers of powers. So if you remember correctly, if I have y to the 5th power raised to the 4th power, I'm going to take the two powers, or the two exponents, and I'm going to multiply them together. So that would then be the same as y to the 20th power. If you did it the long way, just to kind of show you, how many y to the 5th powers do I have? I got 4 of them. So if I did it the long way, I could do y to the 5th times y to the 5th times y to the 5th times y to the 5th. And now you can see how why we multiply these two together, because here I would be multiplying 5 y's together, just like here, here, and here. So then if you take a look, that would give you 20 y's altogether. So that's how we get y to the 20th. Here's an example of where we need to deal with reciprocals. Okay, remember, this negative does not mean -4. It means I want the reciprocal of the base. So another way to write this would be 4 to the 4th over 1. So now I want the reciprocal of that, which would be 1 over 4 to the 4th power. And that would be good if we just left it like this, but 4 to the 4th power, we can also evaluate that. So 4 to the 4th power is 4 times 4 times 4 times 4, which is 256. In our next examples, we're just taking a look at simplifying these monomials. Again, we're calling them monomials because we want to deal with one term. So again, what I have here is z to the 0 power times z to the 3rd power times z to the -6th. Now the one thing that might confuse you guys would be the fact that we have here negative z to the 0 power, and that negative. When taking a look at that, we know that anything to the 0 power is 1. But it's tricky because negative z to the 0 power is the same thing as saying -1 times z to the 0 power. So z to the 0 power is that 1 that we're talking about, but then we got to take that times -1. So then that part answer is -1. And then I have z to the 3rd times z to the -6th. Now I have the same base, and in which case we're going to take our exponents, 3 and -6, and we need to add them together. So we have z to the 3rd plus z to the -6th would be times z then to the -3rd. So then what we have to understand is I need to take the reciprocal of this. So this would be then 1 over z to the 3rd power. And I want to take that times -1, or -1 over 1. So in that case it would be -1 over z to the 3rd. And that would be my answer. Another way we can do this is you could simply, well, I won't do it longhand. We'll just move right on to the second one here. In our second example, we have negative 5ab to the 3rd and times 2a squared b to the 4th, and then all that raised to the 2nd power. So again, we can take a look at how many 2ab squareds b to the 4th do I have? How many of these do we have? We have 2. Okay, so we all know that the quick way to do it is to just distribute and raise everything to a power, in which case this would be 2 squared times a to the 4th times b to the 8th power. Because again, what do we do when we take powers of powers? We multiply. So I'm going to take that and I'm going to multiply it times -5ab to the 3rd power. So now we're going to multiply things together. I can clean this up. 2 squared would be 4. So negative 5 times positive 4, that would be negative 20. And then we have a, and then that's the same thing as saying a to the first, times a to the fourth would be a to the fifth. We add the exponents when we're multiplying. And then b to the third power times b to the eighth power would be b to the 11th power. And that would be my answer right there. The second example, though, I do want to kind of show you the long way. So when we look at it, okay, negative 5ab to the third. Well, that's the same thing as negative 5 times a times b times b times b. Again, this is another way to do it. And then over here, we're going to multiply this times 2a squared b to the fourth. And then I want to take that to the second power. So what are we saying here? How many 2a squared b to the fourth do I have? Well, I have 2 of them. So that I can say then 2a squared b to the fourth, and then 2a squared b to the fourth. So what I can do here then is make this longer. So then 2a squared would be 2 times a, and then b times b times b times b. And over here we got 2 times a times b times b times b times b. So when you do it the long way, you can just see everything in what you have. So now I've taken care of that. So basically now here we got 4, and 4 times negative 5 would be negative 20. And then how many a's do I have? Well, I have 1, 2, 3, 4, 5, so that would be where you get a to the fifth. And then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's where my b to the 11th comes in. So it doesn't matter to me how you do it. If you do it the long way like this, or if you use the tricks and rules that we've talked about, you're still going to get the right answer. In the next one, we have 4y to the 6th divided by negative y to the 8th. So again, we can go the short way and simply know that I'm taking a power of a power. So I can say, well, that's going to be 4 to the 6th power times y to the 12th power divided by negative y to the 8th power. So from there, I can evaluate. I can deal with what is 4 to the 6th power. So 4 to the 6th power would be 4,096. And then I need to deal with y to the 12th divided by negative y to the 8th. Okay. First of all, we have a positive divided by a negative, which would be a negative. And then we have here 12 minus 8. Remember when we divide divide these powers and they have the same base, which is y, we simply subtract the exponent. So 12 take away 8 is 4. So then we're dealing here with y to the 4th power. So because we have a positive divided by a negative, then my answer is negative. So 4,096 times negative y to the 4th, okay, a positive times some kind of negative, I could put it out here then. A negative 4096 y to the 4th power would be a fine way to write it. And that'd be your answer for that particular one. And again, another way to do this is the long way. How many 4y squareds do we have? We have 6 of them. So I can say 4y squared times 4y squared times 4y squared, 4y squared, and 4y squared. Now I want to divide that by negative y to the 8th power. So again, 4y squared, I have all these, so then 4 times 4 times 4 times 4 times 4, that's where we get our 4096. And then we can deal with our y's. So here's 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. I better do a sixth one here, huh? 4y squared. So now we get our 12, and y to the 12th divided by negative y to the 8th. Again, we subtract these two, in which case we get negative y to the 4th. So either way, a long way or short way, doesn't really matter. We can get the same answer. In the next one, we have negative 20 x to the 5th, y to the negative 7th, divided by 4x to the negative 3rd, y to the 3rd. So here we go. We're going to take and start with negative 20 divided by 4. That's a basic fact, which is going to be negative 5. So the next part we have would be x to the 5th divided by x to the negative 3rd. Again, I'm going to subtract. So 5 minus a negative 3. 5 minus a negative 3. We're going to add op. So that's going to be 8. So that's going to be x to the 8th power. And then y to the negative 7th divided by y to the 3rd. Negative 7 minus 3 more would be y to the negative 10th. And y to the negative 10th, we would have to write it as its reciprocal. So that's going to equal 1 over y to the 10th. So then my final answer becomes 5x to the 8th over y to the 10th. Because again, this negative means I want to put y in the denominator. Okay, y to the negative 10 is the same thing as y to the negative 10 over 1. So then I change it to its reciprocal, which is 1 over y to the 10th. All right, some more simplifying here. We're going to take negative 6 to the 3rd power. We're going to take x to the 3rd, which is going to be x to the 9th. And we're going to take y squared to the 3rd power, and we're going to get y to the 6th. We're going to divide that by 3 squared x to the 10th. 5 times 2, we'll distribute that in here. And then y squared. Okay, so then we got a value. So we're going to have negative here. 6 to the 3rd power is going to be 216. So that's negative 216. X to the 9th, y to the 6th. Divide that by 3 squared would be 9. And then we have x to the 10th, y squared. Then we can clean this up. Negative 216 divided by 9 would be negative 24. X to the 9th divided by x to the 10th would be x to the negative 1. And then y to the 6th divided by y squared would be y to the 4th. So the only thing I need to do is clean up this x to the negative 1st power. Okay, which means I'm going to put x in the denominator. So my final answer becomes negative 24 y to the 4th x over x to the 1st, or x, doesn't matter either way. Going ahead and erasing. In our next example, we'll notice here that first of all I have the whole fraction is in parentheses. So I'm going to take the whole fraction to the 2nd power. So we're going to clean that up and say, well, that's 2 to the 2nd power times x to the 12th times y to the 6th. I'm going to divide that by x to the 18th, and it would be y to the 8th. So that would be that fraction cleaned up. And we're going to want to multiply that times x to the 21st power y to the 15th power over negative y to the 33rd power. So now I can divide, I can clean up within the fraction again and then multiply. So like I say, we can kind of divide and clean up this fraction and clean up this fraction and then multiply the two together. Or you could multiply the numerators all together first and the denominators together second, and then clean up and reduce that fraction. Either way doesn't matter. I think I'm going to show you, let's multiply all of this together first. So I'm going to take 2 squared times x to the 12th y to the 6th times x to the 21st y to the 15th. So when you do that, 2 squared is 4. X to the 12th times x to the 21st is going to be x to the 33rd. Y to the 6th times y to the 15th would be y to the 21st. Now I'm going to multiply all the bottom ones together. X to the 18th times 1 is x to the 18th. Y to the 8th times negative y to the 33rd. Well, a positive times a negative is going to be a negative. And then y, and then 8 plus 33 would be 41. So we're almost home now. Now I got to just simplify this fraction. So I'm going to have 4 x to the 33rd divided by x to the 18th. Remember, I'm going to subtract exponents. So 33 minus 18 is going to be 15. So that would be x to the 15th power. And then the last one we have would be y to the 21st divided by negative y to the 41st power. I would subtract 21 minus 41 and get negative 20. Again, a positive divided by a negative is going to be a negative. So negative y to the negative 20th power. So we all know we have to clean that up, okay? And all I need to do is then put y in the denominator. So my final answer becomes 4x to the 15th over negative y to the 20th power. And that would be my final answer there, right there. All right, do a few more, shall we? You guys try this one first, and then you can watch me solve it. So I'm going to look at this one, and I'm going to multiply. I'm going to take the power of a power first. So 3 to the 3rd power is going to be first. Then I'm going to go x to the 3rd and get x to the 9th. Then y squared to the 3rd power is going to be y to the 6th divided by 9x times y to the 12th over x to the 4th. So now again I can either multiply all across the top, all across the bottom, and then simplify, or I can simplify each fraction first and then multiply. Really doesn't matter. I think I'm going to multiply across the top and across the bottom again. So my plan is to take 3 cubed times x to the 9th times y to the 6th times y to the 12th to get a new numerator. So 3 cubed is going to be 3 times 3 times 3, which is 27. X to the 9th and then y to the 6th times y to the 12th would be y to the 18th. And then we got 9x times x to the 4th would be 9x to the 5th power. Now I can clean it up. 27 divided by 9, well that's 3. X to the 9th divided by x to the 5th is going to be x to the 4th because I subtract exponents, and then y to the 18th. And that would be my final answer for that one. So we're going to do 12 to the 3rd power. 12 to the 3rd power is going to be 1,728. And then x to the 4th to the 3rd power would be x to the 12th. And then y to the negative second to the third would be y to the negative sixth. Divide that by 4 to the third power, which is 64. X to the negative 3 to the third would be x to the negative ninth. And then y to the sixth times to the third power would be y to the 18th. And then we can take 1728 divided by 64, which is 27. And then x to the 12th divided by x to the negative ninth, we got to subtract. So 12 minus a negative 9 would be adding up to make it 12 plus 9, which would be 21. So that would be x to the 21st power. And then we would take y to the negative 6 minus 18 more. So that would be negative 6 plus another negative 18, which would be y to the negative 24th. So then I can simplify that by, again, taking this and putting it in the denominator. My final answer would be 27x to the 21st power over y to the 24th power as my final answer. All right, writing our equations that are geometric. Okay, we're going to find the eighth term after we do this. So again, what do we need to know? Well, I need to know this formula. Y is equal to a times b to the x power. A talks about your first term that you see. So here's my first term, 3. B talks about your common factor. So how are the numbers changing? And then x talks about the term you want to find, minus 1. So in looking at these problems, I go from 3 to 1 and 1 to 1/3. If I want to find the common growth factor, I simply take a number in the middle, 1, and divide it by the number ahead of it. 1 divided by 3 is the fraction 1/3. So that's my growth factor. So y then is going to be equal to a, which is my first term, 3, times the common growth ratio, 1/3. And then I'm going to take that to the x power. So that's my equation. Then if I want to find the answer to that, I would take y is equal to 3 times 1/3 to the eighth term minus 1, which would be 7. So to finish out, I would take 1/3 to the 7th power and get an answer, and then take that times 3, and when you do it, you would get 0.0013717742. You could also write these as a fraction, in which case 3 to the 7th power would be equal to 2,187. So that would be in my denominator. And then 3 times 1 would be 3. So there would be my fraction, 3 over 2,187. And actually I can reduce that, divide them both by 3, and I'd get 1 over 729. So whether you want to write it as a fraction or a decimal, it really doesn't matter. In my next example, I start with 4, then I go to negative 16, and then I go to negative 64. So when I take a look at it, 4, negative 16, negative 64. So again, if I want to find my growth factor or my factor, I take negative 16 and divide it by 4, and I get negative 4. So 4 times a negative 4 would give me my negative 16. Negative 4 times negative 4 would not give me negative 64. So this is not even a geometric term. I think this is just a mistake in the slide. So let's just make this positive 64, because now I can use my pattern. So my growth factor, or my factor, common factor, is negative 4. So if I wanted to write my equation, it would be y is equal to the first term, which is 4. Multiply that times my common factor, negative 4, and then I'd put that to the x power. If I want to find the eighth term again, I plug in the number 7. So then y would be equal to 4 times negative 4 to the 7th power. Negative 4 to the 7th power is 16,384, and then you take that times 4, and you get negative 65,536. In our last example, we got 4 to 8, and then 8 to 12. So again, I'm going to take a look at one number and divide it by the number in front of it. So here we have times 2. But the problem is we don't have times 2 in our next example. So then I can say then that this right here is not geometric, and I cannot write an equation. Our next problems involve scientific notation where you're not able to use a calculator. So I want to take 1.2 times 10 to the 4th and raise that to the 3rd power. So what I need to do is take 1.2 times 1.2 times 1.2. 1.2 times 1.2, you should know that 12 times 12 is 144. And then 1 times 1 is roughly 1, so there's where my decimal goes in that answer. And now I want to take 1.44 times 1.2. In which case, when you do that, you're going to get 1.728. So that's how you deal with the first part of the number to the 3rd power. And then I'm going to take 10 to the 4th to the 3rd. So that's going to be times 10 to the 12th power. And so there's my answer in scientific notation. If I wanted to turn that into standard, I would simply take this decimal and move it 12 places to the right. In our next example, we're going to divide. So I want to take 9.3 and divide it by 3.1 first. Again, that shouldn't be too tough. How many 3.1s are 9.3? There would be 3 of them. Again, this would be the same thing as saying also 93 divided by 31. So if you really wanted to do it longhand, you just simply do 93 divided by 31, and you would say 3, and you would see that that would give you 93 with 0 remainder. So these two, 9.3 divided by 3.1 is 3 times 10. And then 10 to the negative 5th divided by 10 to the 9th, remember we subtract them. Negative 5 minus 9 more would be negative 14. So then that would be my scientific notation answer. If I wanted to turn that into a decimal or write it in standard form, I would simply take the decimal, which in 3 is right there, and I would move that decimal 14 places to the left now. In our last example, I'm going to take 4.2 times 10 to the 3rd and multiply that times 3.1 times 10 to the negative 6. So I need to take 4.2 times 3.1. So that's going to give me 13.02. And then I'm going to take 10 to the 3rd times 10 to the negative 6. Remember, now I'm going to add those two together. 3 plus a negative 6 is going to be times 10 to the negative 3rd. Okay, so then notice now that this is not in scientific notation. I need to move that back one, so this needs to become 1.302. And then we're going to go times 10. Now because I moved the decimal in 13.02 back one to 1.32, that's going to change this because we're moving it left, and because it's negative, now I'm going to move it down one, so then my answer is going to be to the negative 2nd. Now it's going to be my answer. Equation examples. If I'm going to deal with a linear function, you all know that that means a straight line. So linear functions are going to be f of x or y would be equal to mx plus b. They make straight lines. They can make lines that go up at an angle. They can make lines that go down at an angle. They can also make horizontal lines. That would be in the form of y equals some number. And they can make vertical lines, in which case that would be x is equal to some number. But exponential functions look different. That would be f of x is equal to a b to the x power. So you're going to also look at graphs for exponential functions. Remember, if I have some type of whole number, so let's say 4 to the third power, anything in here is whole number, I'm going to get some type of exponential function that does this. It's going to go up as I go from left to right. Again, this part will never hit the x-axis if this is the x-axis. My graph will never, ever hit that x-axis. It'll get really, really close, but it will never hit. Okay? If I have a fraction in here, say f of x is equal to something like 1/3 to some exponent, now I'm going to get an x, if this is my x-axis, now I'm going to get some type of exponential function that does this. And again, it'll get really, really close to the x-axis, but it will never touch. Okay, so that's going to be exponential where I have a fraction. Okay, we also can call this exponential growth. Here would be exponential decay. And looking at all those like that. So that's what functions look like and what their graphs would look like. Linear means straight lines. Exponential means we're going to have these curved. And whether you're dealing with a whole number where we're going up or whether you're dealing with a fraction and it goes down, that's what we're taking a look at right there. And another final piece to remember, and I can kind of take a look at, slide this graph up again. We talked about how if I have an exponential function, say y is equal to 1/2 to the x power, I know that it's going to be something that looks like this. But also remember, fractions can be turned into decimals. So also if you saw something like anything that has a decimal in here for the a times b to the x, I would also get this kind of graph when it went this way. Final thing I want you to remember as far as formulas, and you'll still be able to use them. If I'm talking about exponential growth, we need to be looking at y is equal to a times 1 plus r to the t power. And here you simply always plug in whatever your time component is. If I'm talking about exponential decay, then we're going to talk about y is equal to a times 1 minus r to the t power. And then the final thing about r, remember that rate has to be expressed as a decimal, not as a percent or a fraction. So this concludes your Chapter 7 Carousel review. Hopefully you work through these and understand what we're doing, and I wish you good luck on the test tomorrow. Have a good night.